morning to one and all present here. Myself and Kalpana. I am from G.K.Jain Higher Secondary School, Roypur. Today for the 12th standard, I am going to explain the topic is P block elements. So P block element which will be having the group numbers from 13 to 18. The first group, 13 group is the boron group. In last video we saw about the important compounds of the boron. Borax, boric acid, as well as diboron. In the last video we saw the preparation of borax and boric acid. Now the preparation of diborane. So the formula for diborane is B2H6. It is a isolable boron. Isolable means which has been easily separatable. Okay. The diboron, so the formula is just a simple one, a combination of boron as well as the hydrogen. But it cannot be able to prepared in a simple method, that is not be in a direct method. Like boron react with the hydrogen to form a diboron. It is not been possible. So we have to be prepared by some other ways, like sodium borate to NaBH4, which is in presence of iodine. It has been present in the diglycine solvent. So diglycine is which is the combination of diglycol methyl ether. Okay. So it is a solvent. So it has been present in this. It is a high boiling point also. It is a very specialized solvent which is having a high boiling point. So it has been used in it. Then we got the diboron, sodium iodide and hydrogen have been evolved in it. And the properties of diboron, which is a colorless one, it has been a sweet smelling, and even if it is having a sweet smelling, it should be very toxic in nature. At a room temperature, it should be in a gaseous state, and it should be a highly reactive one also. And next one, at a higher temperature, that means when the boron it is under the high temperature, if you are increasing the temperature, it will be yielding the higher boron. That means, for example, let's see that B2H6 is the boron which is under the high temperature like 388 Kelvin, which will be formed as a B5H11 and the hydrogen gas have been evolved. So if you are increasing the temperature, automatically the boron numbers, that means higher, you getting as a higher boron, like a diboron, triboron, pentaboron, tetraboron, like this you have been getting. Okay. And if it is on the hot, red hot condition, that means increase in a more way, it should be formed as a red hot. In the red hot, it should be formed as a boron. You can get the boron in a simplest way. Okay, these are the boron group. And the 14th group is the carbon group. So we know about the carbon. Carbon, it is in the combination of carbon monoxide, carbon dioxide. We have evolved the carbon dioxide which has polluted the environment, etc. etc. So under the carbon group, we have been seeing the silicones. Okay, silicone is nothing else. It is a chain polymer. Chain means it is a combination of number of atoms. Polymers means more number of units it should be having. Mono, single, dice, double, tri, triple. Like poly means it should be having a number of units are there. Okay, the general formula for silicone is R2SiO. Silicon, oxygen, R, where R is the alkyl. What is mean by alkyl? A simplest form of alkane is a methane, like a CH4. If we have removed the hydrogen from the alkane, it will be formed as a methyl. So it should be a methane, CH4. Removal of hydrogen from the methane, it should be formed as a methyl. So that will be a alkyl group. Okay, so from the alkane group, you have removed the hydrogen, it will be formed as a alkyl. Okay, let's see the example for that. CH3, CH3, Cl, Cl. So you have to one hydrogen, it is be replaced by the Cl. So automatically RCl, CH3, CH2, that means C2H5, R, alkyl, some other alkyl group and Cl. Okay, and next one, 2RCl plus silicon will give R2SiCl2. So from this is the basic one. So silicon, 2 alkyl group is present in an RR and 2 chlorine group. The chlorine group which is present, which have been easily replaceable by some other element. And it has been under the hydrolysis, 2 molecules of water. You know that water will be the cation. It has been present both the cation as well as the anion, H plus and OH minus. Here it is also been negative 1. Cl is also been a negative 1. So the Cl, it has been easily replaceable by the OH1. So automatically what happened? Si In place of Cl, it has been replaced by OH. The same compound which has been 2 molecules means we have to remove the water from it. So for finally we get SiRR. Here whatever it is there, and the oxygen. It is the basic unit for the silicon. The basic unit for the silicon is SiO. So combination of silicon and the oxygen, which is the basic unit. So I already told that it is a chain polymer. That means it has been formed as a number of chain groups, as well as it is being a polymer. It is a simple basic unit. So it has been present more and more number. That is why it should be a chain polymer. So the silicon, the basic unit is SiO. After the silicons, it should be silicates. Silicates is the combination of silicon as well as the oxygen. The general formula for silicates is SiO4 4-. Okay. Let's see the types of silicates. Ortho Silicates, Pyro Silicate, Cyclic Silicates, Chain Silicate, Sheet Silicates. First see the Ortho Silicates. So I told that SiO4. Si4 oxygen will be there. The first, second, third oxygen in the same plane, and the fourth one will be in the behind it. Okay, so it should be like a 3D imagination. If it has been in a 2D, we can never be shown the behind structure. So usually it has been OO, only the 3 oxygen will be there, and the fourth oxygen have been represented at the center of the, in place of silicon I have been placed it. Okay. Here no oxygen cannot be, nothing, it has been shared with it, just it has been bonded only. Okay, so this is the Ortho Silicate. So Ortho Silicates, no oxygen, it has been shared with it. And next one is the Pyro Silicate. Whatever it is the basic things, based on the same thing, based on the sharing, it has been classified on that. And second one, Pyro Silicate. The Pyro Silicate is two compounds of SiO4-. The same structure will be there. Here it should be a 3D structure. We have been shown the fourth one of oxygen. Here it is not. The simplest 2D structure is like this. So here one oxygen, it has been shared with the 2 compounds. So in the Pyro Silicate, one oxygen, it has been shared with the 2 compounds. And next one, cyclic. Cyclic means 2 oxygen, it has been paired. Here one, here one. So the 2 oxygen, it has been paired, it has been shared with the other silicate groups. So it should be formed as a closed ring, like a stars it has been formed. And next one, chain. Chain, it is also been having a 2 oxygen, but it is will be in a crossed way, in a upper way and the down way. It should be in a crossed way. And next one is the sheet silicate. Sheet silicate, 3 oxygen has been formed. It has been formed like this way. If it is like this, no, star like that. So it is the combination of 2-3 stars have been formed. That will be called it as a silicate. So these are all the types of silicates. Okay, in this lesson we have expected questions on what are the p block element and how many groups are there present in the p block element, anomalous nature of first element in the p block element, and next 13th group, boron group. What are the compounds formed in the boron group, how it has been prepared, and what are the compounds in the carbon group and how it has been prepared. These are all the expected questions in the p block element 1. Okay, thank you.